not, I think, on both of these, right?
Yeah.
All right, number 11. F of x equals 1/4 x to the fourth minus x cubed. And it says on the interval from -2 to 2. Remember, this is an interval. It is not, in fact, a point. And so I have to plug both of these in before I find the average rate of change.
Yeah.
So I'm first going to do f of -2. I so appreciate your enthusiasm, Malaya. That's appreciated. So 1/4, and then I have -2 to the fourth minus -2 to the third. 2, 4, 8, 16. 1/4 times 16 minus -8. 4 minus -8, which is 12, right? So this gives me the point, not the interval. This is an interval. This is a point, -2, 12. I need 2 points to find average rate of change. So now I'm also going to plug in f of 2. I plug in the bottom and the top of the interval. All right, yeah. The -2 and what? Right. All right, so this is what they gave me. So I take this number first and I plug it into the equation, right? And then I take this number and I plug it into the equation. What I get each time is the y part of that point. So for this one, it's -2, 12, because 12 is what I got. And then this one is 2, -4, because -4 is what I got there. Because I plugged in the x values. Remember, the interval is always in x values, okay? So now it's just a matter of finding AROC, which is just another fancy word for what? Slope. Average rate of change, which is slope, right? So I'm going to do, so AROC is, and I remember this is that delta y over delta x, or change in y over change in x, or y2 minus y1 over x2, or rise over run. Any of those work, right? 12 minus -4 over -2 minus 2. Watch these signs. You shouldn't get a 0 in the bottom here. If you did, it may be because you messed up on your sign. It doesn't matter which one you start with, so long as you start with that same one on the bottom also. Yes. All right. Shh. Lots of individual conversations, guys. Y'all stay with me. Yeah. Okay, so it doesn't matter. I'm going to get the same thing. If I started with the -4 and I did -12 over 2 minus -2, I'll end up with the same thing. It doesn't matter which point you start with, so long as if you start with this point up top, you also start with that point in the bottom. So it doesn't matter which one you start with. All right, so I got 16 over -4, which is -4. What's the average rate of change for that one? -4. Yeah. Seven. So again, this one, it's giving me the interval, right, Rhett? And not a point. So I need to plug that interval in. With my rubber band. Yes. So I'm going to plug in f of -1 and f of 5. When I plug in the -1, I get -1/2. But when I plug in the 5, So these are kind of nasty values, but that's okay. I can still work with them. It's just going to be a little bit harder. So this is the point -1 what? -1/2. And this is the point 5/5. All right, now let's set up our little AROC equation, right? Subtract the y's up top. Again, it doesn't matter which one you start with. If I have a positive and a negative, I tend to start with the positive. So I might start with this one, but it doesn't matter if you didn't. But because I started with 5/8, then I need to start with 5 here, right? If you use your calculator, if I was doing this one, I'd probably put this in the calculator, this in the calculator, and then do a math enter kind of situation. If I get a fraction, here's what fraction did you get up top? +1/2. 9/8, and then what do you get in the bottom? 6. And I don't want to divide by a fraction by anything. Instead, I want to multiply by a reciprocal. Yes. Now, if you have, I don't know that I did so much in Algebra 2, but calculus, everybody always says I do voodoo math. I tend to cancel out and simplify here so that I don't have to work with such big numbers. In other words, I can divide both of these by a 3 before I start. If you don't see that, go ahead and get 9/48 and then reduce. You should get 3/16. Yes, that's half of it. I simplified before I multiplied. You could multiply first and get 9/48, and then you could divide both of those by 3 and get 3/16. It doesn't matter. You don't have to. But it makes it quite convenient and easier. All right, guys. All right. Okay, 13. All right, guys. Usually girls are the chatty ones. It's my boys in here. All right, I'm going to do f of -3. And I'm going to do f of 8. Okay. -3, I got 2, and I'm going to run a little bit faster through this one so we can get on with what we got. -6 minus 1/1, which is what? -7. And f of 8 would give me 2 times 8 minus 1/8 plus 4, which is 15/12, which is 5/4. So for my AROC here, okay, minus -3 minus 8. All right, Harris, here's another fraction for you. -7 minus 5/4. Here's my magic math again. I got 3/4.
I got negative 3/4.
Got a negative up top and a negative in the bottom. It's going to give you a positive.
Okay.
All right, let's flip over to the symmetry sheet. Any questions there? 5. Okay. Number 5. Number 5 gives me an equation. Remember I told you you did not have to do this one algebraically, only graphically. So what kind of symmetry does this one show? Does it show y-axis symmetry? In other words, is it even? No, because the y-axis is not, you can't fold it on the right. This one you could fold it on the x, so you could do x-axis. I told you you didn't really have to do the x-axis symmetry, but if you did, that was okay. How about origin? That's rotational. So if you put your pencil on the origin, you flip it completely upside down, rotating around the origin, does it look the same? 180, right. Does it? Yes. Does it look the same? No, because one of them's opening to the right and one of them's opening to the left. So they don't look the same. It's just x-axis. Remember, this is that, please let me be able to pull it up. Yeah. We're fixing to do that. All right. This one says algebraically. Algebraically, boys. How do I tell if it's even, odd, or neither algebraically? You make the x negative, so I'm going to do negative x, which gives me the square root of negative x minus 4. And then I'm going to look at it, and I'm going to say, okay, does it look exactly the same as what I started with? No. Does it? Yeah. That's what you always do to check algebraically. Every time.
So wait, if it looks the same.
Yes, if it looks exactly the same, every sign has changed, everything's positive. I mean, everything's opposite, then it's odd. So this, right. So this one is a neither, and this one is a neither because it's not, there's no way it's going to be completely opposite and it does not look exactly the same. Odd.
So if the negative belongs outside of the square root, would it have been on?
Yes. So if you had plugged in and you got this, yes, that would be odd. Yes. All right, 13. How would you get what? You wouldn't be able to this way. I was saying that's what an opposite would look like. All right, look at 13. And it looks like all the ones y'all are asking about are the neither ones because you don't know. And if you get confused like that, it's probably going to be a neither because neither one of the situations is happening. Neither. It's not going to flip it to positive. It's not going to flip it to positive. You can't do it like that. To solve an absolute value, it doesn't solve that way. You have to set it to the positive and the negative. But it was, yeah. Number 11. All right. I got to make y'all see. I have got to remember to do that today. I don't usually have to do that by the time y'all get to pre-cal. I'm a little disappointed. Yeah, let me know if you need to stay at the front. Not like right now, but let me know. So 11, f of x is negative 4x cubed plus 9x. So I'm going to plug a negative x in. And so I've got negative 4, negative x to the third plus 9 times negative x. And so what happens here is when the exponent is odd, it's causing it to keep its sign. But when the exponent is even, it's always positive, right? So negative x to the third is negative x to the third, right? That gives me, the negative stays. What's a negative times a negative? A positive, so I got 4x cubed. And then here, this is a negative. So if you notice, all the signs are completely the same.
So it's odd. Oh, that makes sense. Hey, I'm good. How are you? Oh. So number 7, y'all got. Yeah. Okay, that makes sense.
Okay, so the ball is not clicking. Literally not clicking. Every step? Yeah, exactly. Does she have a mouse? I thought she used like a pencil or something. It's not clicking. It's not clicking. At the same time, and I was trying to get somebody's attention up here, and I couldn't get anybody's attention. Okay, it's okay, it's okay, it's okay. All right, what y'all got? I forgot even where we were. Did I answer your question about this one? Did we finish that one? Okay. Oh, use the points on the graph for that one. So that one is, it says from -5 to -2. So you literally go to the graph, you go to -5, and at -5, what's the point that corresponds to that? 1, 2, 3, 4, 5. It looks like -2. And then at -2, what's the y that corresponds? 7. Do a rock between those 2 points. Yeah. Yeah. She just. It's rotational symmetry. If you turn it upside down,
Oh, positive.
me, Desmos. Nope. This is the one we were talking about the last time I saw you. I don't even remember what day that was. But that's rotational. Several of you asked me origin rotational symmetry. That's odd. That's all the same thing. That's the one that looks like that, where if you turn it upside down, it looks exactly the same. That's rotational symmetry. 180 degrees.
I was wondering why I was getting advocated scientific rotation.
All right.
Okay, so remember when you got three?
Do I get 3 for number 1 on the AROC page?
Yeah.
Yep.
Okay.
There you go. This is going to be your notes and your homework. We're going to get some started together, and you'll finish filling out. What? Whatever you prefer. Whatever you prefer. But here's the thing with these. Now, we were due a quiz, but with everything, I feel like with everyone out, and then we had a bout of sickness through here, and it seems like we're still having some sicknesses go around. We kind of missed our last quiz, and rather than going back to that right now, I think you were supposed to have a quiz before we did symmetry and AROC. Because we did continuity, that's right. You were saying it seems like a long time, and it does. Remember, we had continuity, which was you don't have to lift your pencil. You got jump, you got hole, you got removable, non-removable. Yeah. I think probably tomorrow we will have a quiz. Continuity, AROC, and symmetry. And normally I wouldn't tell you. We'll get you made up. Several of you won't be here but I'm gonna have time. I know. How many junior leadership? How many people does that? 2, 4, 5, 6.
Or Thursday.
Okay, so let me, because I want to get to the ones that we really need to spend the most time on, okay? All right, so we'll start with linear. The parent function is already graphed here for you. We're talking about no slides, no reflections, no shrinks, no stretches, just the parent function. So for linear, that is just f of x equals x, or y equals x. That is the parent function. That is the name of it. So you've got some boxes here. Should I pull this up and like write on it? Absolute value of x, yes? All right. Domain on this guy. That's right. Negative infinity, infinity. Left to right. So it goes left forever, it goes right forever, and it's never interrupted. I always look at it like this, from the furthest left, and then as you keep going across, there's always graph. Would it be what? No, range, what's the lowest? Range describes y. What's the lowest? 0. Can it be in a bracket? Because it can be 0 up to infinity. Okay, x-intercept, 0. Y-intercept, extrema, Okay, and I want you to say that. That's perfect. Absolute min, and now give the coordinates. 0, 0. All right. Increasing intervals. Where does it increase? All right, so look, remember I read a graph the same way I read a book, left to right. So if I start over here and I move left, am I going up or down? Down. So this is my decreasing interval, which means this one is my increasing. So now I just have to describe it. 0 to infinity. Now, remember, I use X to describe increasing and decreasing. Y'all wanted a review for that quiz, so this is a good review. Decreasing. Negative infinity to 0. These, I use the X values to describe it. So X goes negative infinity this way, positive infinity this way. Yes. In behavior, same thing as the other. As X approaches infinity, f of X approaches infinity. Boys. As X approaches negative infinity, f of X approaches what? Oh, we said the same as the other, but it's not the same as the other. Both ends go up on this one, right? The left side goes up and the right side goes up. So as I look at the right side, the graph goes up. As I look at the left side, the graph goes up. Right. Both ends go up. Not on this one, no. No. You only use that whenever there's another arrow on the graph. Like, if you flip over to the back and you look at the reciprocal one, that one you would. All right, discontinuities. Can you draw it without lifting up your pencil? Yeah, I could trace one here, never have to. So none. It's even. How do you know it's even? This is like a mirror. What's the difference? What? So you could do that. Did y'all hear the question? What happens if you try to do it algebraically? In other words, if I come in here and I say, okay, what is f of negative x? Well, that would be negative x. And this absolute value, because there's nothing else in here but just the x, that becomes positive x. So it looks actually the same, which gives me the even. Like I could say this. All right. I'm going to leave you these two for homework, and I'm going to flip over to the next page. The solutions are posted on Canvas for these. Do I have index cards? No. The solutions are all posted on Canvas, this whole sheet. All right. If you recognize some of these, let's see. We did this one. We did that whole first page a lot in Algebra 2, as we did square root and cube root. Okay.
Let's do, we'll do square root. We'll do square root. All right, the parent function here. Square root of x. However, on this one, what is the domain? 0 to infinity with a bracket, right? Because there's a point right here at 0, 0. How about the range? 0 to infinity. X-intercept. 0. Y-intercept. 0. This time, that's right. This time it has an absolute minimum at the point 0, 0. Maximums and minimums. Yep. How about increasing intervals? 0 to infinity. It never decreases because as I move left to right, it never goes down. So none. In behavior. As x goes to infinity, f of x goes to infinity. How am I going to describe this end right here? Because it clearly ends right there, but how do I describe that? As x goes to 0, f of x goes to 0. The closer x gets to 0, the closer y gets to 0. Does that make sense to everybody? Discontinuity. None. Even though it breaks and it's just that one piece, I can draw it without lifting my pencil. So no. Even, odd, or neither. It's neither. It's neither because the y-axis does not mirror the function, and if you turn it upside down, it definitely looks different. So it's neither. Yeah, I'm gonna do that with you. I'll tell you what, I think what I'm gonna do with you is I'm gonna go through reciprocal with you, and we're gonna stop at reciprocal, and I'm gonna let you in class do quadratic, cubic, and cube root, and then tomorrow we'll do exponential, logarithm. We'll do these others because you haven't seen those before. So all right, so look at what it's doing right now, right? It's going up to the right. If I flip it upside down, it's not going up to the right anymore, it's going down to the left, so it doesn't look exactly the same. Odd means it looks exactly the same when you turn it upside down. All right, let's look at the reciprocal one because this is a brand new. Remember we did the rational functions algebraically? We're getting ready to do the rational functions graphically. And this is the parent function for them, okay? This is what we call the reciprocal. And reciprocal means what, by the way? Flipped. I'm thinking flipped. Opposite fraction, which is flipped. So it's 1 over x. Now, when you think about this, what can you never divide by in a fraction? What causes you to be undefined? 0. 0 causes what we call an asymptote, and this time a vertical asymptote. X can never be 0 in this case. And so that's how I know for this one, there is a vertical asymptote that you don't see on here, but it's there. It's invisible. It's a boundary. It's in the middle. The parent function also has a horizontal asymptote at y equals 0. So I've got these two asymptotes that are going to cause me some problems, but if you know that they're there, it's going to help you with your domain, your range, your discontinuities, all that good stuff, okay? All right, chess. All right, domain here, left to right. Be careful when you answer this. Left to right. Furthest left it goes is what? Negative infinity. So I'm looking at this piece right here, right? Because that's the furthest left piece. So I got negative infinity. And then remember, I'm taking my pen like this. As I go this way, up, roadblock, right? 0. 0 is where that happens. That's exactly right. It's going to be in parentheses because that's an asymptote. I can't be 0. I can hug it and I can get really, 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 really close, but I can never actually be 0. So I put a parenthesis. I connect it with a U because then it picks up. Look, it hugs this side of 0. It's like 0 is the only thing. It's this very, very minute little line that sits here that it hugs on either side, but it can't actually ever touch it. So I leave out just 0 on my domain. Does that make sense? Okay. It's painful, but we can do it. So yes, range is going to be exactly the same because in this case, this asymptote is happening again at 0. Now again, this is the parent function. Nothing has been split, nothing's moved, and so the zeros make it a little bit easier for me. But it's the same thing. The lowest it goes is negative infinity, and then as I come up, I don't hit a problem until I'm at 0. So from negative infinity to 0, U, 0 to infinity. Is anybody confused by that? All right, x-intercepts. None. If there's an asymptote there, it can't cross. It never becomes, right? X-intercept means it crosses the x-axis, but there's a boundary keeping me from crossing, so I can never cross, so it's none. Y-intercept is the same thing. It's none as well. Asymptote is not actually a part of the graph. It's a boundary there keeping the graph from touching, but it's not a part of the graph. It's saying it can never be that. That's why you don't see it. I drew these little dashes so you know it's there, but it's not like part of the graph. There's no extrema because look, I go up forever, down forever. And remember what extrema means. I stop increasing and start decreasing, or stop decreasing and start increasing. If that never happens, I can't have a max or a min. So in this case, look what's happening as I move left to right. Am I increasing or decreasing? Decreasing. Even when I come up here, guess what? Still decreasing. So there's no extrema. So that's exactly right. And we kind of just talked about that. There's also no increasing intervals. But my decreasing intervals, if it's always decreasing, then all I have to do is take my domain and copy it down here. Because whatever, remember I use X to describe increasing, decreasing. If it's always decreasing, then it's going to be whatever my domain was up here. All right, in behavior, how many pieces should I have for this? 4 this time, right? 1, 2, 3, 4. Every arrow gets an in behavior, okay? All right. Let's start left and move right because that's generally what we do with graphs anyway. As x goes to negative infinity, what does the graph do? It goes to the asymptote. What is the y value of the asymptote? 0. So as x gets smaller, y gets closer to 0. Is that true? As x gets smaller and smaller and smaller, the y value gets closer to 0. That's very true. Now this, as x approaches what? 0, but 0 from only one side, because this side's also approaching 0. How do I determine, how do I distinguish that it's just the little plus or the little minus? So which one is it? Am I approaching from the negative side or the positive side? From the negative side. So I'm going to do a little negative. Then y is approaching what? As x gets closer to 0 from the left, that's exactly right. Y approaches negative. That's your minus. That's your negative. That says from the left side. For the other end? Uh-huh. Yeah, we're gonna write the other two. Yeah. Is that what you're saying? Is that what you're talking about? I don't think that's what. Oh. There's another part to it. Yeah, there's a counterpart to it. Okay, let me show you. All right. Now we've got two more ends, okay? I'm gonna do this little quickly so you see that I'm separating because I'm 4 in behavior statements. All right, this one. X is still going to 0, it's just doing it from the other side. So as x goes to 0, but this time from the right, what is the graph doing? Infinity, because it's going up. This one's going up. Right. Right, right. The plus tells me from the right, the minus tells me from the left. Plus is right, minus is left. 0, as x goes to 0 from the right. So we're talking about this one right here. This one is as x goes to 0 from the right. This one is as x goes to 0 from the left. No. So now the last end, which is this arrow, is as x goes to infinity, what does it do? It goes to 0. Yes, yes. Discontinuities. Yes. Infinite. Remember, these are also, we only use x to describe these. Okay, so yes, I have an infinite discontinuity at, and you have to say where it happens, at x equals 0. I'm using x, always describing with x. X always tells you where, y always gives you a value. Because it's an asymptote there. Asymptotes make infinite discontinuities always. Even, odd, or neither. Odd. This one is odd. If you flip it over, it looks exactly the same. If you put a negative in here, it would just make the fraction negative, which would mean completely opposite. All right, I know you don't have long, but I would like for you to do quadratic, cubic, and cube root. You might not have time to get through all 3 before you leave, but those should be a review. And so tomorrow together we'll pick up with some exponential we actually did, but we'll pick up with some of these new ones tomorrow too.